This section is not in the book, and it's an extension. We're going to be solving exponential and logarithmic inequalities. Very similar to the rest of the inequalities that we have solved. We're going to solve them like regular equations, but we do definitely need to check the domain on the logarithms. So let's go ahead and look at the exponential side first. So 4 raised to the x is greater than 7. We can use the inverse, so we'll rewrite it as log base 4 of 4 raised to the x is greater than log base 4 of 7. And so by the inverse property, that cancels, and x is greater than log base 4 of 7. If you plug that into your calculator, you can either use the change of base formula and do log base 10 of 7 divided by log base 10 of 4, or natural log. And so we get x is greater than approximately 1.404. So if we write that in interval notation, it would look like that. And there you go. And there's no domain restrictions on inequalities, so that's all the values that would satisfy that inequality. Let's take a look at the second one here. Base 2 and base 8, we know that we can write these with the same base, so we go 2 raised to the x plus 1 is less than or equal to 2 raised to the third raised to the 2x minus 3. And so that'd be 2 raised to a power you multiply, so that's 6x minus 9. And now that the bases are the same, we can use the one-to-one property to say x plus 1 must be less than or equal to 6x minus 9. Subtract the 6x, subtract the 1 to the other side, divide by negative 5, so our inequality needs to change from less than or equal to greater than or equal to, and so x is greater than or equal to the value, or to the number 2. And once again, interval notation is the bracket on the 2 to infinity. Just a reminder, the other thing that we can do with any of these inequalities is we can create a number line and the solution, and then test a value on this side and test a value on that side and see whether they're true or false. So that will work as well with these inequalities. The next set of questions we're going to look at is logarithms. So log base 3 of x plus 5 is less than. So we need to use inverse properties on this one. So we'll say 3 raised to log base 3 and 3 raised to. And so that's the one-to-one property. And then the inverse allows us to cancel the log base 3. So we're left with x plus 5 is less than 3 to the second, which is 9. So x is less than 4. Now here's the thing. Remember that the logarithm, this value right here, must be greater than 0. So we also have to include that as part of our solving. So we need to know that x plus 5 is greater than 0, which means x is greater than negative 5. So not all values less than 4 will be solutions. You have negative 5, greater than, those are your possibilities, and then 4, less than, those are your actual solutions. Both of these have to occur, so therefore the only solutions that will work are the values between or greater than negative 5 and less than 4, except I put infinity, so less than 4. So there's your answer in interval notation. So once again, this is the one you have to check your domain as to what values can possibly even work for x for the logarithms. Alright, on the next example, we got natural log of x plus 1 plus natural log of 3 is greater than 1. So we're going to use the product rule to combine the natural logs. So this would be 3 times x plus 1 is greater than 1. Now we can use the one-to-one property to say e raised to both powers so that we get the natural log to cancel. Distribute the 3, so that'd be 3x plus 3 is greater than e to the first power, and e to the first power is e, or 2.71828, and so on. We'll leave it as e to the first for now. So if we solve for x, we subtract the 3 and then divide by 3. So x is greater than approximately negative 0.094. And then once again we have our domain. So the domain is x plus 1 must be greater than 0, which means x must be greater than negative 1. We also have a second natural log, but it is already 3, so we don't have to worry about the x value because there is no x value there. So we have two things. We have x is greater than negative 1, and we also have x is greater than negative 0.09. So on this one, the domain doesn't restrict us any more than what our solution already did. So our final answer is negative 0.094, all values that are greater than that. Alright, example 3, A and B. Go ahead and pause the video and try these two on your own. These are the last two examples we'll be doing on this section. Alright, we got a natural log is less than a natural log, so the one-to-one property allows us to say that x plus 1 must be less than 5. And if we subtract 1, we get x is less than 4. Once again, we need to look at the domain, and x plus 1 must be greater than 0, so therefore x must be greater than negative 1. Think about how that plays into your solutions. Values that are less than 4, but then we also need values that are greater than negative 1 because that's your domain. So we can't have anything less than negative 1, otherwise it won't make sense in terms of your logarithm. So therefore our solution is all values between negative 1 and 4, or x is greater than negative 1 and less than 4. Alright, and the last one here, we got log of x minus log of x minus 1 is less than or equal to log of 8. So we're going to use the quotient rule and have log of x divided by x minus 1, and this is base 10, is less than or equal to log of 8. So we can use the one-to-one property to say that x divided by x minus 1 must be less than or equal to 8. Multiply both sides by x minus 1, so it'll be x is less than or equal to 8x minus 1. Subtract the 8, and then divide by x, and once again, because you divided by a negative, the inequality will flip, and its x is greater than or equal to 8/7. Now we need to look at the domain, and we actually have two restrictions here. The first one is just the x. So here we know that x must be greater than 0. The second one is x minus 1. So here we know that x minus 1 must also be greater than 0, which means x is greater than 1. So even though the first one could be 0.5, it wouldn't satisfy the second logarithm. So we got to make sure that we're looking at all the domain restrictions and the solution to make sure it satisfies all three of them. So if you want, you can do a number line here, and you have 0, 1, and then 8/7 is a little bit bigger than 1. So what we have is greater than 0, greater than 1. So even though 0.5, like I said, would work for the first one, it won't work for the second one. And then the last one, it must be greater than or equal to 8/7. So it has to satisfy all three of them. So it looks like it will actually just be the solution that we originally found. But once again, we can't assume that. We have to check the domain to see if it is. So we have all values that are greater than 8/7. So interval notation, we'll have a bracket on this one because 8/7 is a solution. And so that's it in terms of solving exponential and logarithmic inequalities. Right here, write your summary for this section of the notes in the lesson.